Okay, we have passed 2 minutes past 3 now. Welcome to this seminar at the Danish Sound Cluster. My name is Torben Vilsgaard. I'm director of the Sound Cluster. When we launched the first newsletters on the webinars, we didn't really knew how many would participate. So today we have more than 128 participants scheduled for this meeting. So we are very pleased for the big support we're getting from our members here. So thank you. Before we go to our capacities on the Bluetooth technology, a few words on what we're doing here. We'll be running a number of webinars during the autumn. From mid-August, we plan to launch 1 webinar per week on different issues. And in the meantime, please follow our newsletters to be totally informed of what's going on here. Yeah, I will not bother you with more details on the Danish Sound Cluster. You can always go to our webpage and get more information if you like. I will hand you over to my colleague, Signe Thomsen, who will come up with some practical information on how we run this seminar. Signe, please.
Thank you very much, Torben. So I'm Signe Thomsen, working as a product manager at the Danish Sound Cluster. Before we get started with the webinar, I just have a couple of practical, technical questions. So first of all, we will run several presentations. And how do you communicate with us during the presentations? First of all, if you have any questions regarding the presented topics to the speakers, please use the Q&A function, the Q&A. For all other questions, for chat and some other kind of chat, please use the chat function. And as you see, there's a colleague more of ours, Muriel, and she will take care of the chat function. After this webinar, you will receive an evaluation link, and we will be very pleased if you would help us sharing your reflections on the webinar, but also have you got any other ideas for coming webinars. And when we finish, also it'll be one of those days, we will send you also an email with the presentation slides and other relevant links. That was all from me. Shall I?
Thanks, Signe. You can see from our matching backgrounds, all of us from the Danish Sound Cluster here. So in order, before we hand over to our presenters, we're going to run a poll to see who's here today. So I'm going to start that. There are 2 questions, and the first one is we would like to hear which industry you work in or which field you're working in. And the second one, if you scroll down, we would love to hear what your experience is with Bluetooth technology and how you're using it in your products today. Excellent. We can see the votes coming in. This is just our second event, so it's very interesting for us to see who is here. We know that there's a lot of interest from the hearing aid companies, but we're sure that there's some others out there as well. Also to check who's listening. Over 85% people. Okay, let's stop it there. So we can see that, there are a lot of people from the hearing aid industry, consumer electronics. Great. And a lot of people who already have experience with Bluetooth but would like to learn more. Perfect. Thanks a lot for sharing. So now I'm going to hand over to our guests for today. First of all, we have Nikolai Bisgaard, who works for GN Hearing and has worked for a long time in many different departments. And now he is a consultant on the application of the new Bluetooth standard. So he will give a presentation. Then there'll be a few minutes for questions at the end of that. And then we have Nick Hun, who is the founder and CTO of Wi4 Consulting. And for the past 30 years, he's been closely involved with short-range wireless and communications, designing technology that helps to bring mobility to products, particularly in the areas of telematics, M2M, smart energy, IoT, wearables, and mobile health. He is also the project leader on the hearing access profile for Bluetooth. And then after his presentation, there will be a discussion together with our other guests here. We have Lukas Ramanovsky. He's been working with Bluetooth since 2007. He co-founded his company codec in 2015, and he supports clients with integrating Bluetooth into their products. He's also an open source enthusiast and contributed to many projects. He recently focused on the LE audio specification development and in bringing it into the Android open source project. So I know that Lukas is interested to hear how many of our guests today also use open source platforms. And finally, we have Bo Schmidt, who is the VP in Research and Technology. He's been with the GN Audio for the last 15 years, and he's also managed the selection and introduction of wireless technologies, including multiple generations of Bluetooth. So I will hand over to Nikolai. Thanks a lot.
Thank you.
Nikolai, he will share his presentation.
Yep, it should be coming
And
up.
thank you very much for being here today, all of you.
Yes, so I trust that you can see my screen now. And just to reiterate a little on the program here, we've had some introductions. So I will give an overview of the key features of the new Bluetooth system that is coming. And Nick will dive into some of the more technical aspects of it, and then we will have the panel discussion at the end. So Bluetooth. Bluetooth is called themselves a trade association. It was established years ago by a group of people from some of the telecom companies trying to make a short-range wireless connectivity system. They named it after a Danish king called Bluetooth, who lived around 958 or something like that, for not so well-known reasons. The Bluetooth system has over 36,000 members in 150 countries. So it's a huge group of people interacting through Bluetooth. They do the specifications for Bluetooth, they qualify implementers, and they promote the results. And Bluetooth is very successful. Here you can see the number of devices shipped annually with Bluetooth, either in the platform device or in a device that can connect to the platforms. And as you can see, we are talking millions. There's a projection for the future as well, of course, but still it is an impressive number. The type of applications that Bluetooth is mostly used for is audio streaming. So Bluetooth is really the way to transport sound around for a lot of people. Data transfer is also an important application. The little devices you can wear on your wrists, sports devices, fitness devices, and so on. And then some other applications as well. But today we will stay focused on the sound part of it. A few comments about Bluetooth and hearing aids. Classic Bluetooth is quite a challenge for hearing aids because the time division multiplex mode that it works in causes very short but very high power drain episodes, which is tough to handle for the batteries used in hearing aids. So for many years it was seen as an interesting opportunity, but not a realistic one. The Bluetooth low energy version that came years ago was certainly a big help to this problem, but it lacked support for audio, which of course was a bit of a nuisance in that sense. So then in 2014, there was a proprietary audio solution developed for Bluetooth low energy by Apple and a couple of hearing aid manufacturers. And that sort of worked for some years, but it was clear that the hearing aid industry wanted a real Bluetooth standard that included the audio aspect of it, that would be suited for hearing aids, so we could have an open standard that was available for everyone. And this is what now finally, after many years of struggle, is on its way and very close to being introduced. And the low energy audio thing brings about some very important new aspects. The hearing access profile is a low power profile that will particularly suit hearing aids. And it involves also a new codec. The codec is the system that encodes audio, transmits it over the wireless link, and then decodes it into sort of hearable audio again. That has been one of the other issues with the classic Bluetooth, is that many of these codecs were kind of slow and caused a relatively long delay. If you listen to recorded music, the delay doesn't really matter. It means that your music starts 200 milliseconds later, not a big deal. But for hearing aids, as I will come back to, it can be quite a problem. It also supports now true multi-stream, so you can have two stereo channels transmitted at exactly the same time to two devices who are sort of co-presenting the program material. And then finally, the one that is really exciting, I think, at least we think in the hearing aid industry, the audio sharing. This is a broadcast mode, which is quite a new thing for Bluetooth, that gives some very interesting opportunities, both for assistive listening in the hearing aid field, but certainly also for many other areas where this could be used for amazing new applications. Hearing aids have been used with what we call sound reinforcement systems for many years. And the reason is that hearing aid users often struggle with poor signal-to-noise ratio and reverberation. And the way to deal with it has for many years been the loop system. A loop system is a magnetic loop that is picked up by a telecoil in the hearing aid. And I think we can, without insulting anybody, say that this is a very mature technology. It has been around for the past 40-50 years. It has low latency. It is exclusive to hearing aid. Nobody else is using it. And it's quite easy to use. The downside is that the audio quality is poor, and it is very susceptible to interference from modern electronic systems. It's difficult to isolate spillover from one room to the other, particularly if they are on top of each other. The deployment cost is quite high. There's no privacy, and that is maybe the worst part, it's not available everywhere. So let's just dwell for a moment on sound reinforcement. Here is a picture of scenery where here is a speaker, and you can see his microphone around here. So he's talking to the audience. There's also a PA system that will behind him, probably sending out his speech in loudspeakers. And down here at the far end, we have a guy with a hearing aid, and he would like to pick up this. And he has a hard time because of the reverberation and people chatting. So he has a need for a direct transmitted sound being fed into his ears. And direct sound travels about 330 meters per second. So if the distance between the speaker and the listener is 16.5 meters, it takes 50 milliseconds. And in order for this to sound proper, though the two signals should arrive approximately at the same time. It's not important that it's exactly the same time, but reasonably within the same time frame. And this is why real time and latency matters for the hearing aid applications, because this sound reinforcement scenario is one of the key scenarios that we would like to service with this new broadcast technology. So this means that encoding and decoding should be possible within approximately 50 milliseconds. And that is where this LE audio comes in, because broadcast is a feature of the new system. Bluetooth has coined the name audio sharing for it. And the point here is that you can have an unlimited number of endpoints, as they're called, or syncs. So this is quite a a considerable deviation from the usual way of Bluetooth working, where you do some sort of handshake between two devices saying, we negotiate how we're going to talk to each other, and you know me and I know you, and then we can start transmitting signals between the two. In the audio sharing, the streamer, the source, advertises how it's doing it, and anybody can pick it up, but the source would never know anything about who is picking it up, very much in the same way as FM radio. And that is sort of the novel thing, that there is no negotiation between the parties. So if you want to pick up a broadcast sound, you should be capable of aligning yourself with the information in the broadcast advertising. Oh, that was the wrong way. So this is exciting for the hearing aid field, that we can do much better sound quality. We have a new high quality codec. We can have more installations. Of course, it's going to take some time before every hearing aid is Bluetooth LE audio enabled. We haven't seen any of them yet, but they will come out over the coming years. And therefore, we will, of course, see the Bluetooth broadcast system grow in parallel with the loop system for a number of years. Ease of use and confidence in the system are critical factors for success here. Hearing aid users are not necessarily the most tech-savvy people you've met. Many of them, the majority, I think, are aging people, 70 or above. And to them, it matters whether this is complicated or easy. And as we know, and those of you who know a bit about Bluetooth, it is a relatively complex set of specifications. And that is, of course, because it is designed to be usable by so many different applications and so many different companies. So the specifications allow for an enormous a wealth of various specification aspects that you can set it up with. We in the hearing aid industry are a little concerned that enormous flexibility is going to lead to situations where some people will have a bad experience and not be able to connect, or will have issues with it. So we have set up a working group under HEMA. HEMA is the Hearing Aid Manufacturers Association, to define the parameters that will be used in our version of the broadcast system. And the working title for this is HearStream. And HearStream is sort of a layer on top of the Bluetooth system, where we will define some further details of how to set it up in order to ensure that there will be as good as possible interoperability between hearing aids and the streamers that hopefully will be put out there over the coming years. We will develop a signpost that you can put up on the wall saying, here is HearStream, and anybody with a hearing aid should know now that this should be easy. You just push a button or whatever your sort of supplier of hearing aids has decided that you should do, and then you should be able to connect. And this sort of IP, you could say, will be owned by a HEMA, and you will need to somehow agree that you will follow those guidelines if you want to get access to using the logo. And all of that is not done to sort of be possessive about it. It is done to make sure that the hearing aid users are going to have an uncomplicated experience with the system. So there are more people to it than just the hearing aid users. I mean, they want high quality directly to the hearing aids, ease of use, and we all realize that a smartphone is a great way to offer additional services and lists of sources and what have you. Unfortunately, we can't rely on every hearing aid user having a smartphone, so it has to work without that as well. But it's also important to know what those who put up the streamers in public places, what they want. So they want clear announcement of availability to the users. They will also have a desire to limit access. If you have to buy a ticket, you will probably not be qualified to listen unless you bought the ticket, for instance. And they are also very keen on confidence that it works. It's for people with hearing aids. They're not the majority of their customers. And there should be some way to know for them that I checked it, it actually works. So they can have confidence that it is in place when people need it. And this is sort of the ecosystem that we are looking into here. We have the users who are keen on certain features, mostly simplicity and ease of use. We have on the right side here the loop system manufacturers who traditionally provided the loop systems. They would like to go into this business of wireless streaming with Bluetooth. So they are represented by their association. Hopefully, we will have regulators active as well to say it should be reasonable that any public venue where people can come with hearing aids, they should have one of these streaming devices so you can have your sound directly to the hearing aids. All of that is being worked on by HEMA at the moment. So where can you imagine this to work? I mean, here's my local church, and on the wall there is a little sign. That is my interpretation of how it could look, made some years ago. It's probably not going to look like this, but the idea is you put up such a signpost, then people know inside it will work. You could put a QR code on tickets, so you can scan the ticket with your phone, and then you will know exactly what to present. Oh, why is it running it by itself here? You could even imagine that you do it on a platform for trains, so you could get the messages about how the train runs directly to your device. That could be hearing aids, it could be other devices too, actually. And there's a number of scenarios that we are going to explore in the coming years. At home, streaming from music, radio, at counters, a public channel, but still at counters you need privacy. You don't want all the other people in the room listening into your conversation. You could have it in taxis. Meeting facilities poses a particular challenge because they typically have a dynamic allocation of rooms. You can get it into one big room, you can make it into smaller rooms, and each of these rooms should have one of these devices. You could even imagine that in shopping centers you have security related messages like fire alarms or whatever. But in order to make things work where it matters the most, we will focus on public sound reinforcement systems in the typical places where we used to have the loop system, churches, theaters, concert halls, places like that. But there are many applications beyond that. You could imagine language services. The new Bluetooth system enables that you can have many parallel streams going out at the same time. So you could imagine a system here where people are sitting with headsets and they can listen to 6 different languages simultaneously instead of having to have these little odd headsets they often use in such venues. One example, airports, we all know the silent TVs. Why do you have to read the little ticker line below? Your headset or your earbuds or whatever should be able to connect to the TV and you can hear the sound. Same goes for waiting rooms, gymnasiums, sports bars where you have typically 4 different programs running at the same time. But of course silent because otherwise they will interfere. You can hook on to the one you want by taking out your smartphone, watching what's channel I would like to see or listen to. Conference centers, we talked about, cinemas, but also just personal sharing of audio. We all know the sight of teenagers with one white earbud in the left ear and the other person with the right ear. Now they will be able to share it with their own earbuds. And then not just 2, but as many as you want. So there are really some amazing applications. Yes, and that is sort of what I'm going to say about this so far, mostly at the application level. Nick will cover some of the technical details. So the question now is, do we have any questions?
And the answer is yes, we have one from our participants. Why can't you have a telecoil analog audio reception by HA or an accessory and then digitize it to HA at Bluetooth, BLE?
That is also technically possible, but not a very elegant solution, I might add. We think that in the future, all hearing aids are going to have Bluetooth anyhow. And the transmitters that will do the streaming audio with Bluetooth are such, I wouldn't say cheap devices, but definitely less complex devices to put up and administer. So we think this is the technology of the future, and there is definitely an opportunity to have sort of intermediate devices where people would like to exploit the loop system, but it's going to be so easy and inexpensive to put up these streaming devices that I think in a few years we will see them in parallel with all the loop systems anywhere.
All right. And now we have a few more questions coming in. One from Neo at Bang & Olufsen. What's the sound quality level on hearing aid version if you compare it with typical codecs? How would music sound, for example?
Well, I'm happy you asked that. It sounds really good. And there is, if you go to the Bluetooth website, you can actually listen to a demo. And I think if you go for the highest bit rate, even the very discerning people at Bang & Olufsen will find it quite satisfactory, I'm sure.
We'll have to test that. Excellent. And we have one from Eddie B. Brixton. Is it possible to scramble the individual channels of the multi-channel function?
To scramble the...
Shall I answer that?
Yeah, you please do.
Can we encrypt the audio? The answer is yes.
Yes, okay.
Okay. And that is all the questions we have at the moment.
All right.
From our audience.
Sally, can I interrupt?
Yes.
There was one question coming in the chat coming from Chris. Is 50 ms the minimum latency possible with BLE?
Again, if I jump in on that, no, the minimum that we're likely to get is about 25 milliseconds. That will depend on the codec sampling rate. You can get shorter than that, but you then start to lose robustness. But 25 milliseconds should be good enough. And the other question coming up, which is preempting what I'm going to say, is the only limit to the number of receivers you can have for broadcast is the number of people you can physically put within range. So depending what your social distancing requirements are, not a lot at the moment, but very, very many once we all get back to hugging each other.
I mean, I can add here that I've did some experimentation with this years ago where I put up a TV streamer, which is a proprietary device for our company, but will function in the same way. And I mean, we had a meeting room which was like 30 by 40 meters, and I had 50 sets of hearing aids distributed across the room, all coupled to that streaming device, and it worked beautifully. And you could even leave the room and come back, and you could hear it in the hallway, some part of it. So I think it's going to be a lot of people. It's functioning, as I said, quite much like FM radio, you know. Anybody who is in range can pick it up.
Yeah.
Thank you very much. I do not want to interfere with the chat, but I would like to. I think a lot of people came in after we explained that we would like to have the technical questions about this topic. It's coming in through Q&A. And I think Sven Shepstone has had an answer to his question, but we have a last one coming in. Which class of op-amps does LE use?
Op-amps?
If you mean what transmit power do we use, that will differ in different countries. Depending where you are in the world, you're looking at transmit power of between 10 milliwatts and 100 milliwatts. In practice at 10 milliwatts, we're seeing ranges of about 30 meters. So certainly filling an average size public space, but you can have multiple transmitters if you want to go beyond that. There are also issues that, depending on the size of antenna in the hearing aid, and if you've got a very small hearing aid that almost fits inside the ear, it's not going to be as sensitive. So that may also affect range. But the aim is that with one broadcast unit that's running at quite low power, you'll certainly be able to fill most normal rooms where people meet, and public spaces where people meet.
Thank you very much.
All right. I think we've answered all the questions from Nikolai's presentation. So if you're all ready, then we can move on to Nick. And I forgot to mention that Nick is the leader on the hearing access profile for Bluetooth.
Okay, so, thank you.
Thank you very much, Nick.
I'm hoping you can see the slides. What I'd like to do is to run through a quick introduction to the Bluetooth LE audio specifications. This work all started about 8 years ago. It's taken a long time to get here. And it was very much at the instigation of the hearing aid industry, who wanted Bluetooth to look at a lower power audio solution, which would be applicable to hearing aids and the low power batteries, or the small batteries that you have in hearing aids. So we started this back in 2013. A year or two afterwards, we suddenly got all of the phone companies and the consumer electronic companies coming along saying, that sounds really good, can we join in? And it's ended up looking at a complete new generation of specifications for audio. Current specs we have today are about 20 years old. We're hoping that we're developing a set of specifications that will stand us in place for anything that comes up in audio for the next 20 years. I know that's a very big claim to make, but we have had a lot of people feeding into this to try and make it as flexible as we possibly can. And unfortunately, that's one reason why it's taken so long. We've got about 20 specifications in total. There's probably about 1,000 pages of them. All I'm going to do today is just provide a very quick overview of what the different specifications are and how they fit together. If anybody has more technical questions, we have a Q&A at the end, or I've got my details in the presentation. Please come and ask me questions. So, a brief history of Bluetooth audio. We started it all off in 1998. We were going to do 3 things with audio in those early days. We were going to design it for headsets, and that was mainly thought of in places like call centers. We were going to do intercoms. That never worked. And we were going to use Bluetooth to replace cordless technology, but DECT came along, so that one didn't happen. Which I suppose is a warning sign that when you give engineers ideas of what do you go and do, they'll probably get quite a number of them wrong. We started with a very simple headset profile. We made that more complex to cope with cars with a hands-free profile. And then back in 2005, we added in music streaming, which was the A2DP profile. Took about 5 years for that to go anywhere, and it only really took off when Spotify came into existence and it started to be possible to stream music. Since then, it's taken off. As we've seen today, it's the biggest application for Bluetooth. We're running up to about 1.5 billion users. Last year, I've seen estimates that almost 600 million earbuds shipped out of China. The numbers are quite stunning. And it's very much taken effect in line with the growth of streaming customers, which I think shows an interesting one, that it isn't just getting the technology and the hardware right, you need the content there as well. The other thing that we've seen driving things is the introduction of voice assistants. We all talk to Alexas or Siris or Cortanas nowadays. And we're starting to use voice again. After 10 years in which music dominated in terms of audio, we're starting to see voice make a comeback. Not just in talking to machines now, but even things like podcasts. Voice is becoming important. And we're seeing applications where people are looking at how do we use voice more. We spent quite a lot of time in the early days of this saying, well, can we take what we've already got with Bluetooth and just make it a bit better? And when we looked at what we're doing today, we're actually, with classic Bluetooth, quite close to the edge of what you can do. We don't have much room to move to try and get lower power or lower latency or higher quality, because there's just not enough airtime given the number of bits we need to transmit. And when we look at the new topologies, like trying to stream to a separate left and right hearing aid or earbud, when we want to do broadcast, it just doesn't work. So we ended up really having to sit down and say, we need to think again from a clean sheet of paper. Given we've now got 20 years of experience of audio, how do we do it better? And there are issues today with multi-profile. If you want to stream music and send a voice command at the same time, it just doesn't work. You actually have to stop the stream underneath you're changing your profiles over. It can look quite seamless, but there's an awful lot of stuff happening in the background, and we wanted to make it simpler. We also were concerned with the bigger audioscape, and by that I mean it's the number of devices that use audio. If you just look around your office or your house, we've got all of the things that we immediately associate with audio, TVs, laptops, headset speakers and the like, which are obvious audio devices. But we have hearing aids, we have doorbells, we have ovens and microwaves that talk to us. And we needed a way to try and bring all of that together so that people can fairly easily make up the combinations of what they want to talk to each other. And that will change as you go through the day. A lot of Bluetooth today is about doing things with particular pairs of devices, like your phone and your car, or your phone and a pair of earbuds. And the realization is that we're going to be changing what we use and how we use it far more often. So we wanted that flexibility. And we also wanted to cure those problems. So lower power, lower latency, better quality. We wanted to replace telecoil. But one of the important things we thought about is the telecoil experience, that sound reinforcement, is really important to hearing aid users. When we talked to normal consumers and said, if you could do this, if you could just have conversations with people, maybe at the supermarket checkout without taking your earbuds, or if you want to hear the bus time when you walk up to a bus shelter, would that be useful? And everybody comes back and says, well, we'd really like that as well. We don't just want those things to be there for people with hearing difficulties. So we're trying to build something that works for everyone. So that's where we started. The first thing we needed to do was basically get out the spades and dig the foundations for it. And that all happens in what we call our core specification. This launched in the version 5.2. And we introduced something called isochronous channels to Bluetooth Low Energy. Now, when Bluetooth Low Energy was designed, it was really designed for devices that stayed asleep for most of their life. They just woke up to say, this is the temperature, turn the lights on, doing simple stuff like that. And with audio, you want something that appears to be on the whole time because it's transmitting audio data. So we had to design a completely new form of Bluetooth digital connection that supported that audio data. As Nikolai has been saying, some of the times it's much like classic Bluetooth. I just want to take a call off my phone and receive it on my headset. But we also wanted that broadcast where everybody in the room can listen to the same thing. We want the ability to make it private. So if you're in a bank and you want to have a conversation with a banker, you can still use this, but it's encrypted so nobody can hear it. And if you're at home and watching TV and you're using broadcast on your TV, you don't want your neighbors to hear what you're watching. So again, there's applications where we need to put encryption in. Broadcast, as we've heard, is like an FM radio. Everybody who's within range can hear it. But if you've got lots of different channels being broadcast, you have the question of how do I listen to the right one? So we've got a new way of providing what are called advertisements in Bluetooth. That's how a device tells other people it's there, which have information about the content. So if you walk into a venue, you'll get information about which languages are available for you to listen to. Or as Nikolai said, in the pub, in the gym, you can identify the different streams and pick those up. So there's a lot of basic sort of foundations built in the core that let us make all of this possible. Those, however, are only the foundations. We need to put other stuff on top. Now, as we've said, we have a new codec. We've been working with some of our member companies who have provided the technology in this. It's a really new codec, and that being really new is quite important. The SBC codec that we typically use in Bluetooth today is about 40 years old in terms of technology. Even the more advanced ones that you see, some of the proprietary ones from the chip companies, were developed back in the 80s. LC3 really is state of the art. Now, if you go to the Bluetooth website, there's a demonstration of this. You can actually listen to music in full non-encoded form, and you can then see what it sounds like in the different versions of LC3 as we change the sampling and the bit rate. You can get right down to the levels that we're planning to use in hearing aids, and it's virtually indistinguishable from the lossless original. It really is surprisingly good quality. And that means, particularly in a public place where you've got some background noise, we can look at audio bit rates that are less than 1/10 of the lossless originals, and people are not going to notice the difference. What they are listening to is probably going to be driven by the quality of the transducers in their earbuds and hearing aids, and not actually by the codec. And that's quite amazing quality. It's low latency. The codec itself, if you run at about a 10 millisecond frame and you look at the encoding, decoding, and algorithmic delays parts of that, that accounts for about 15 milliseconds of latency. The way we set up the Bluetooth link, we do the repetitions, all of the other management of the stream adds about another 8 milliseconds. So 23 to 25 is the shortest you can get. And that's not really noticeable if you're listening to both this and ambient. But we can really play with this depending on what the application is. I'm now going to try and run through 1,000 pages of spec in about 5 minutes, so apologies if it goes a little bit quickly. Instead of doing lots of separate profiles the way we have before, and if you look at hands-free profile and A2DP, the way they actually work is really quite different. So we've developed what we're calling a generic audio middleware, which contains quite a number of different specs. But the point of that is the generic word. You are able to take bits and pieces of that, like sort of tools out of a toolkit, to do almost anything that you want to do. And there's some more details of this on the Bluetooth website. A basic architecture looks like this. We've got the core sitting at the bottom. We have the codec sitting there for you to use as you want. We have the generic audio framework, which has lots of individual profiles, which I'll quickly talk about. And then on the top, we have the very specific ones for different use cases you want, such as for hearing access, for replacements for telephony and the like. So at the bottom, we have something called BAPS. It's 3 profiles, and those control the way we actually set up all of these streams. We can have as many streams as we want. We can send audio in both directions. We can set up lots of different quality of service, the numbers of repetitions, to try and give you either low latency or robustness, or whatever combination of these you need. And that also means we can arrange these to try and give you really low power consumption on the hearing aids or the earbuds. We have specific sets of profiles that you can take in order to do media control. So if you're listening to TV or music, you can do all of the normal things like play and stop and fast forward. You can do search functions if it's streaming online, so you can get a device to go out and try and find what you're doing. And it will know what you're doing, how you're doing it, and add context. Same thing if you're on a phone call. It doesn't matter whether it's a Zoom call or a Skype call or something off your mobile phone. We've now designed this to cope with any type of telephony, which is something we didn't do well in the past. And again, you can play with all of the things that you get through the 2G up to 5G specs of multiple calls on hold, adding people into phone calls, mixing phone calls and the like. We have an ability to coordinate devices. If you have a left and right hearing aid or a left and right earbud, you want them to try and operate as a pair so that when you connect to something, they both change at the same time. You don't want one of them listening to the TV while the other one's listening to your microwave telling you that dinner's finished. So coordination lets you collect devices together. Typically, in our case, it will be hearing aids or earbuds, but it can be a multi-speaker surround system. But it lets devices understand that they've got shared capabilities and they need to operate as one. We can control multiple microphones, and most earbuds and hearing aids today have multiple microphones within them, particularly if you're doing noise cancellation. We've got very flexible volume control, so you can control the volume of individual hearing aids or earbuds. We can balance between them. We can control what information comes in. So sort of quickly looking at that, this is sort of a typical hearing aid where you might have both a Bluetooth stream coming in, a telecoil stream could be coming in as well. You're going to have your microphones for the normal hearing aid function. So we've got ability to mix and match all of those together and then to balance those between your left and right hearing aids. Trying to make this very flexible. Same if you've got microphones and you've got multiple microphones coming in, we can coordinate the time at which you capture everything. We coordinate the time at which you play everything as well. So if we're sending left and right signals to your hearing aids, we can actually set the time that they play and render to within a few microseconds, not milliseconds, actually down at the microsecond level. And that means you don't get any jitter or a feeling that the sound image is moving around in your head. We have a profile that we call the Common Audio Profile, which is designed to tie all of this together so that those various bits and pieces come together in one sensible way. And then on top of that, we've added what we call the use case profiles that look at particular types of ecosystems, so telephony, media, hearing access, and public broadcast. That should be public broadcast. We started off thinking it'll just be TVs, and we realized it was wider, so we just changed that. And that's essentially, sorry, 1,000 pages of spec in 5 minutes. Apologies for that. The question really is everybody's lips is, when is this coming out? It's taken longer than we wanted, not least because one of the things we do in Bluetooth is we insist that everything is tested before we publish a spec. And we require 3 different companies with 3 separate implementations to perform all of the tests, just to try and give us confidence we haven't made mistakes. We normally do that by getting people together in sort of big conference rooms to literally test devices against each other. With travel restrictions, we've not been able to do that in the last year and a half, so we've had to build up a complete remote testing facility to enable us to do that, and it slowed things down. Now, although that slowed down the adoption, we're hoping to get the rest of these specs published from the autumn to the tail end of this year. But that time has let companies move forward. I'm aware of over 20 companies today that have already announced chips that will support Bluetooth LE audio. Some are already shipping. LC3, anybody can design it. It's in the spec. There's no license for that if you're using it for Bluetooth. People have already designed their own LC3 implementations. We have phones that are already shipping, which have the underlying foundational isochronous channels in. They're just going to need firmware updates in order to make this work. And as I'm sure Lucas is going to tell us in a second, the open source community is already very well advanced in terms of the capabilities and the code that they have to implement all of this. So I'm hoping that, unlike previous Bluetooth projects, where it's been a couple of years delay between a spec coming out and products arriving, we're going to see products coming out pretty soon after we get these specs finished later this year. And at that point, it's really up to all of you and your imaginations as to how quickly we get products out there and just what those products do. So I'm going to stop at that point, so we have time for some questions, and more importantly, the panel.
Thanks very much, Nick. So we have quite a few questions here in the Q&A. Are you ready?
Fire away.
If Bluetooth 5 supports BLE, why do hearing aid manufacturers go to Google for ASHA? I don't know what ASHA is.
Nicola, I think you're muted, but it's one for you.
Here we go. Yes, I think as I said in my presentation, there was in 2014 some products coming out using iPhones. Apple developed together with some hearing aid companies a protocol that added audio to the low energy Bluetooth. And the thinking at the time was that the real thing, the Bluetooth version that we've been talking about, would come out somewhat earlier. That did not happen for various reasons. And a lot of people complained that it was not possible to do the same with Android as we did with iPhones. And therefore, after some years, there was an effort to go along with Android and have the similar thing implemented in their system as well. Once we get the real Bluetooth LE audio out there, I'm sure that all of those versions are going to vanish quite quickly, because it's so much better to have a unified system that works everywhere. So you can see that as a temporary sort of band-aid solution to the problem.
Thanks, Nikolai. And could you explain to me what ASHA means?
I can't remember. Audio sharing for hearing aids or something like that.
Okay, it's a hearing aid.
Yeah, I think so.
Feature. Okay, next we have a question. One thing that lots of users are dealing with is the difficult pairing procedure on the existing Bluetooth system. What about pairing procedure on Bluetooth LE? Does it support smart pairing?
This is an item of frustration, because the concepts of smart pairing came out when we did Bluetooth Low Energy back in 2010. The issue is that a lot of manufacturers don't seem to put a lot of effort into making pairing easy, and it ought to be a lot easier than it is for many cases. I mean, Apple have done a very good job, and what we're seeing is other companies following along and picking up what they've done, trying to copy it. But really, pairing should be effortless. The coordination functions we have help with that. But it's something that I really wish more product designers would pay a little bit of attention to.
Maybe some
I
of them
don't
are
think
listening.
it's a lack in, well, I don't think it's any lack in the Bluetooth specifications. It's just the user interface design.
So if you can be the best at that and make something that works a bit more quickly and a bit more stable. Excellent. Question to Nick. Is there any specific reason why the LC3 has been optimized for 10 millisecond frames? How does the frame length offset robustness?
There's a sweet point for audio codecs. I mean, if you look at most modern codecs and you're looking at latency quality, 10 milliseconds gives you about the optimum. We can run it at 7.5. That makes it compatible with classic Bluetooth, which typically runs at 7.5. But 10 milliseconds, it's the sweet spot for audio codecs. I don't know why it is, and that's based around sort of coding and our own perception of sound.
Do you mean in practice, or do you mean?
This is in practice. It's not just LC3, it's most codecs. If you go down to 5 or 7.5, you can get lower latency, but it's not as efficient in terms of coding. If you go up to 15 milliseconds, you see the latency can start to give you problems, and it's more difficult to get rid of some artifacts in it. It just happens it is the sweet spot in most codec designs. Depends a little bit on the exact codec technology, but most codecs today operate at 10 millisecond frame.
All right, thank you. And one thing that lots of users are dealing with is we've had that one, sorry. Question from John. Is there a specific profile for gaming with chat? Stereo input with low latency and a channel microphone output?
There will be. We basically have the challenge today that everybody is getting involved and saying, I want to do this with it, and we can't do all of them at once. We're starting off with the broadcast, generally aimed at sort of the sound reinforcement telecoils, with hearing aids, with TVs, with phones, and gaming is following fast behind, along with multi-channel surround sound. We have some very, very keen gamers in the specification group who have vested interests.
Good. There's a lot of people out there who will be wanting that. What about proximity range?
As I said before, this depends a little bit on your transmit power. Typically what we're seeing is we get a range of about 30 meters. It depends on where you are. If you're inside, you get lots of reflections off the walls and the ceilings, so you'll get better reception. If you go outside in the middle of a field, or even worse, sort of on a boat in the middle of a lake, particularly if it's salt water, you don't get any of those, and the range goes down. But certainly within a room, within a sort of a decent sort of public venue, you should get that range. And we've done quite a number of experiments in theatres, and for most theatres, other than sort of the largest opera houses, one transmitter will cover all the audience.
Great. Next question from Chris. Is the LC3 Plus spec, it mentions high resolution to support up to 96K. How is this achieved, and what does it mean in practice? Also, how does this function come as standard, and is it available now?
The LC3 Plus is a variant of the LC3. They come from the same source, but the LC3 Plus is for DECT phones. The Bluetooth version, we go up to 192 if you need it. They are basically similar. I think the LC3 version we have with Bluetooth is a lot better tested. That really has been kicked to death by a large number of development companies, including some codec specialists. So we are very, very sure about its quality and its robustness.
Excellent. And another question from Bang & Olufsen from Neo. What's the typical sync lag on broadcasting mode? Do all sources get the same time code or clocking?
The sync lag is variable. You can set up what you want on this. There are some obvious limits here that, because there's no negotiation between any of the receiving devices, any earbuds and headsets, and the broadcaster needs to try and set something up that it expects everything to recognize. We send a synchronization signal out with every broadcast, and that tells each headset when both the left and the right, or if you've got some mutated version and you've got 3 ears, when each of those have received the sound. That is a very accurate point in space. It comes with a recommended point after that when it expects you to render it, because that way you would be in sync with, say, a video screen if that was around. But individual manufacturers, if they want, can make that shorter or longer. So you get the point where you're told all of the devices which have been sent the signal will have received it. Now is the time to start your decoding, any audio algorithms you want to run, and your rendering, and a recommended point at which you do that.
Hope that answers this question. We have a few more questions here, but do you want to move it over to the panel debate and get Lucas and Bo involved as well?
Maybe the last question, I can see the one about what applications are primarily in mind that would make use of the audio encryption part of the stack might be one of more general interest that we could. I think we touched upon it a couple of times that, I mean, suppose if you want to have a audio reinforcement system for hearing aid users in a courtroom, you must be very sure that no information leaves the courtroom to be picked up by bystanders on the outside. Therefore, you need to do some sort of encryption of the signal, and you need to have some sort of convention about how you pick it up and decode it that is only available to the people inside that room. And you can imagine similar situations if you go to a counter in a public office and you signal, I'm hearing aid users, I would like to talk with you over this system. Of course, it has to be encrypted. You can't risk that other hearing aid users sitting in the same room would pick up some part of the conversation. And likewise, you could also imagine in theater, movie theaters, that you need to pay for a ticket to get access to the movie and to the audio as well. And since wireless travels, as Nick said, a bit differently from many other types of signals, that you might be able to stand on the outside and get a pretty good recording of the music track from a movie with wonderful music, which the movie industry hates. And therefore, I mean, there are multiple applications where this encryption will be useful to limit the number of people who can listen in.
And I think the other one, the simple one, is if you just think of TVs in hotel rooms, that those are obviously going to transmit down the corridor, and you don't want everybody else to know you're listening to Fox News or anything else.
Okay, then I think we have answered all of the questions in the Q&A. Should we invite Lucas and Bo to join in the conversation here?
Yes.
Welcome, Lucas and Bo.
Hello.
Thanks for being here.
Yeah.
Is there anything in particular you wanted to speak about today, Lucas?
Yeah, so actually I was thinking about how to implement LE audio. I see that Nick did a great job and present all the pieces we actually need to start with LE audio. But maybe from the practical point of view, so we are working. So when you want to start with implementing LE audio, you need to think about a couple of things. First, about use cases you want to support. And as Nick presented, I see that you guys are very interested in the broadcasting scenario, and I agree this is the most sexy feature, I would say, from the LE audio. And so we need to care about the Bluetooth controller on your device. So your Bluetooth controller needs to be at least 5.2 specification, but maybe even better is to wait for 5.3 when it will be available, as there are a couple of fixes you would like to have. Then you need to have a Bluetooth host supporting all those features from the controller, which is enabling stream, configuring it, etc. So this is very important. And then you need to build on top all the pieces which Nick presented, like all the profiles. I think he mentioned it's 20 of them, but you don't have to worry. There's not all of this you need. As he mentioned, when you want to build your product, you just need to pick the profiles you actually need to create to support the scenarios you like to have. The good thing about those profiles which are needed is that all of them are based on the GAT profile, which is the generic attribute profile. This is that profile comes with Bluetooth Low Energy from 4.0. So all the developers having any experience with low energy has the understanding how to implement profiles on top of these APIs. So this is very helpful for you guys to speed up the implementation of the products. That's all I wanted to say about how to start with implementing that. As usually mentioned at the beginning, I'm very enthusiastic in open source projects. So I want to say that there is indeed a couple of open source stacks, Bluetooth stacks, which will provide support for the LE audio. There are already a couple of them supporting the core specification, which is already adopted and available for everybody. So you can find those implementations out there. And the thing is that those implementations are LE only. So you need to make sure if you want to support dual mode, which means basic rate as well, or only LE only. For LE only devices, you have support from open source. And and the good news is that, as I mentioned, and it's also available on the website, you can see that Android open source project is getting actually LE audio support, which means that you might expect a device which is already streaming using LE audio. Yeah. So that's,
perhaps we should ask Lucas, everyone out there, if they can either raise their hand or write in the chat function, in the chat, if they are using some kind of open source at the moment.
yeah, if we can, we should ask them. It's very interesting for me.
Yeah, they can write it in the chat.
The one thing I forgot about is LC3 codec. So this is also something important. As Nick said, the specification is open. You can just grab it and implement. But you might want to look into the controllers, the Bluetooth controllers you want to use in your product, because those might get support for the LC3 codec. So you will have this is called the offloading functions. So basically your host will not have to spend time on encoding and decoding, but the Bluetooth controller will do it for you. This is very nice function, and if you ever have to pick up the controller for your products, I would consider to look into those. And yeah, as Nick said, there's already a couple of controllers supporting LE audio.
And one thing I'd add to that is, I think with classic Bluetooth audio, we saw the market really become dominated by one or two chip companies who made the chips for virtually everything that's out there. Introduction of LE audio has really reawoken interest, and we have got a massive choice of companies now that are out there making chips and providing stacks, far wider than we had before. And some of those are concentrating on specific areas, for particularly just for low power or for dual mode chips. So there's a lot of interest, activity, and also components being developed to help people do interesting things with LE audio.
Yeah, that's correct. And this is also because a lot of companies probably want to focus only on LE, which is much simpler than basic rate. And such of companies creating such controllers also provide the ways to update the firmware in the fly. So it's, yeah, as you said, it's a much bigger market now.
Is that what you're working with, Lucas, in your company?
So
is to help people decide?
Yeah, that's one of the things we're doing. We also help to integrate the solutions on their product and help with qualification, as this is very important as well, to make sure that the product is stamped by Bluetooth. So yes, that's what we are doing.
I have a question. Oh, sorry. Let's go for the participant question. How do we deal with all these different phones using different chips for different markets? Example, Samsung used their own chip in European models and Qualcomm in their US models.
So the Bluetooth chips has the HCI interface, which is defined by Bluetooth. So this is common interface. So yeah, when you talk to controller, you basically use always the same language. And then the Bluetooth SIG provides so-called the events called UPFs, where actually we all go together and verify the compatibility, that all works together. And yeah, this is how we test devices across each other. And also the Bluetooth qualification process is the one who is making sure that devices with different controllers basically behave the same in the same way when you claim to support specific profiles. So when you say that you support LE audio, you will have to pass a lot of test cases actually to qualify your product. And this also makes sure that you will be able to work with other devices.
And if you're a developer, Bluetooth has a very, very powerful tool called the Profile Tuning Suite, which you can use for testing your implementations, and you can also use it for testing component products that you're working with. That is a really helpful thing I found in my experience of trying to make sure that your product fully meets the Bluetooth standards. Most manufacturers use that, and that's a way of guaranteeing. And then, as Lucas says, we have these unplug fests where you can go together, check your products against each other. There are generally people there with quite advanced test equipment that will let you actually sniff and listen to the radio packets that are being sent to try and find out any issues that you might be having. So there's a whole design infrastructure out there to help support that interoperability.
But does it mean that the qualification will be much more complicated now that you have so many new features? And
I would hope not. We have automated testing systems, and the Profile Tuning Suite provides an automated test that you can literally sit down and take your product through. If you fail any of those tests, then you obviously need to spend time debugging them to find out what's there. But the aim is to make that qualification that really intimately tests every aspect of your product as simple and automated as possible.
So maybe, Bo, could you say a few words about your perspective seen from Jabra or GN Audio's side about this?
Absolutely. So actually, we have been doing Bluetooth product for quite some years, maybe around 20 years, and I've been pretty happy about the technology as such. But we also welcome actually LE Audio because it brings in a lot of new use cases and some improvements in audio quality. So for us as an audio-centric company, it's fantastic technology, and we are looking really forward to introduce this into the market. But with all new technology, of course, it's a challenge on the technical side. Interoperability, of course, is an issue, but it's also the transition from supporting classics to maybe dual mode to come out at the end of the day, maybe with LE Audio only devices. So maybe one question for Nick is how do you see the Android and iOS picking up LE Audio, and when do you actually see that we will see phones with only LE Audio?
If I knew when Apple is going to launch this, I'd probably be able to sell the information, have bought my own Caribbean island by now. I don't know. I can certainly say that phone companies have been very active in the development. They're very interested in what this is doing. They have a vested interest because hearing aid regulations around the world mean they have to put telecoils into at least some models of their phones to meet the hearing ability requirements. If LE Audio is approved by regulators, they can get rid of those telecoils in phones. That saves them a surprising amount of money each year. So that again was one of the reasons why way back Apple first tried to develop its own Bluetooth version instead of putting a telecoil in, but the regulator said no, it needs to be generic and everybody has it. So that's one thing that I think will drive them. The other one is that concept that you can share music from your phone. So if a group of friends come round or your kids go out for a beach party, they all take a speaker with them, they all connect up and it works. And I think for the phone vendors, that's one of the most interesting immediate applications because it's selling to that young demographic who will regularly spend money upgrading phones. For that reason, I think we're going to see this sooner than we might otherwise have expected. I don't think it will be in this year's phones. I think, as Lucas says, they're going to wait for the 5.3 chips, but they're already sampling those, so those will already be being prepared for the phone launches next year. I wouldn't be surprised to see LE Audio appearing in some of next year's phones. We may even see them in some of the spring announcements. I think that would be early, but I'd be very surprised if you can't ask for one in your Christmas stocking next Christmas.
And do you have an idea of when we won't see classic anymore?
Long time. I mean, the reason for that is one of the things that will keep classic in phones is one, it actually is quite expensive to design it out of the chip. If you look at what happens with, I mean, it's not just Bluetooth chips, it's the basic modem chips. If you buy a 5G phone, it's still got 2G in it. because people just add stuff in. Taking it out can be quite awkward. But the real one is, as I said, it's cars. People keep cars for 10 years or so. The automotive industry is also slow to move to new technology. So you'll be able to buy a phone with low energy audio probably 2 to 3 years before you can buy a car with it. But phones won't take classic out until those cars are getting towards the end of their life. So I do think if you've got a phone, you'll have classic in it for at least the next 10 and probably the next 15 years. And you won't know which is being used some of the time. If your earbuds and hearing aids have both, there's going to be conversations going on between the phone and your hearing aid or earbuds as to which to use. And they may use one for some applications and another one for different ones. Most of the radios in the phone that are running Bluetooth are also running Wi-Fi at the same time, and they're time sharing the radio. So there's lots of interesting scheduling stuff happening, which may make a phone decide that one day it'll use Bluetooth Classic and the next day it'll use Bluetooth Audio. And you won't notice, other than the fact that your battery life one day for your hearing aids is a bit longer than it was the day before.
I think actually we're pretty aligned on this. I foresee at least that we for quite some years will provide headset speakerphones with dual mode Bluetooth.
Yep.
But clearly we will also take advantage of doing maybe LE audio devices for some specific applications.
And one of the things we're seeing as well is I think we'll see LC3 being used for classic as well.
Oh, yes,
because it's more efficient, it means you can put more audio streams in, so you can add more people on conference phones or have translation. There's not sort of a brick wall between them. Bits of the technologies will leak across each other.
Yeah. But we clearly need a kind of a new generation of chipset to support LC3. LC3 use a lot of processing in order to encode, decode, kind of 4 to 5 times more than we have with the classic codecs we use today.
Yeah, and that's where Moore's law comes in.
Yeah.
We have a question here from Chan. Can LE Bluetooth and classic Bluetooth work at the same time?
Yes, but we don't think it's going to happen in many cases. Simply because you are doubling up. As I said at the beginning, classic audio's not terribly efficient in terms of airtime. So if you're transmitting a decent quality with SBC for classic audio, you haven't got much room left to add additional LE channels and vice versa. If you have to, you can do it. We have some people that are talking about having multiple Bluetooth radios in a device, so you can do it. The question is just how efficient is it? And I think that's going to depend on whether we actually see it in real products. If you've got, as a normal phone, we've done the calculations, you can run Wi-Fi Classic and 2 LE channels at the same time, but you haven't got time to do anything else. There's just only so much airtime that you have to push the radio bits out if you start doing multiple different things.
I mean, if you are not doing audio, I believe it will just work. There's a lot of time to share. But if you go for audio use cases, that's probably you need to stick to one of them.
Yeah. And if it's a phone and you've got LTE that you've got to put some time aside for as well, it becomes even more difficult.
Maybe I'll just make a comment here that, I mean, we had the questions about Bluetooth pairing and why that doesn't work at times. I mean, I can remember the days when whenever you got a new device that ran on Bluetooth, you also got a Bluetooth dongle along with it, because then the manufacturer felt confident that it would work, and their support department would not be flooded with people saying that, you know, with my computer it doesn't work, and what do you suggest that I do? So therefore you just got this little dongle. provided by the product manufacturer. So he was sure, and I think GN Audio did the same, Jabra did the same for a while. And I think that experience is also why the hearing aid industry is relatively keen on defining a very totally specified version that we will recommend or will demand people to use in order to make sure that we don't get that type of experience out there with the hearing aid users, because they will not be very patient with this. It has to work flawlessly almost in order to become a success. And the only way to do that, I believe, is to really specify it to each corner that you can go into, because it's such a multi-headed affair that just one thing is set wrongly and then you will not get what you are looking for. So I think that is the downside of the enormous breadth of facilities in the Bluetooth system, is that you have to be very careful that everything is exactly set right.
Yeah. And clearly pairing has actually improved. I think Google has its Google Fast Pair, Microsoft has its Swift Pair, and there are other people doing something out there, especially Apple. So pairing has definitely improved.
And there are some initiatives happening within Bluetooth as well to try and make this far simpler.
Yeah, there's a question in the Q&A around mass deployment of devices in the spectrum. I think in GN we do actually mass deploying of headsets in call centers and in large office spaces. It's a different use case and more tough use case than the auto sharing. I think auto sharing is pretty simple with one transmitter, many receivers. So I think that both will have a nice coexistence. I think still Bluetooth Classic and LE Audio will have the same challenges in mass deployment. But mass deployment is actually pretty okay. Pretty good.
And certainly before we had COVID, in London, if you're traveling on the tube, in the trains, you will see carriages full of people wearing wireless headsets. And I think to almost everybody's surprise, that works. We've improved the hopping algorithms within LE Audio, so they should be even more resistant. Yeah, hopefully it will work. One day we might migrate up to other frequency bands as well and get more spectrum, but that's probably 10 years away.
But Nick, is that one of the things that are going to be different with the broadcast system? That you can't sort of negotiate the frequency hopping schemes between two devices to optimize the transmission? Because if you just disseminate something, it will be what it is. And if you can't get it, there's not much to be done about it.
No, the broadcasters all set up their own random hopping system.
Yeah.
Broadcasters are capable of scanning to see which frequencies are in use out there. So it is
okay. Okay.
And if they see that something is changing, they can embed little control packets to tell all of the listening devices that this is going to change in the next 10, 20, 30 milliseconds. Prepare to use a different hopping scheme. So it should be just as robust.
Perfect.
We have a few more questions in the Q&A here. From Chris, is the LC3 bitrate variable, or can the user fix for best quality?
LC3 is almost infinitely variable. We recommend the use of it, that you negotiate at the beginning as to what quality you want to use between your transmitters and your receivers, just to make sure everything stays in sync and that it works. But there is a lot of flexibility if you want to use it.
And Sven Shepstone, did you already answer that one? Related to the current discussion.
I'd actually want to make one point on codecs. And within Bluetooth Classic with SBC, there's quite a lot of variability. What we discovered over the years is the more variability you put in, the more time devices spend just trying to negotiate with each other what they want to do. And we ended up with both HFP and HTTP saying, no, there are these very defined set of standard settings. I think there's about 6 of them in total. Use those. And at that point, everything worked much better. So sometimes it's better to just say, we'll choose a few that we know work and then we'll stick with them.
From Sven, we have related to the current discussion, are there potential issues where classic Bluetooth could hog spectrum airtime in a venue and cause issues for Bluetooth? Ellie, was that related to the hopping?
It's related to the hopping. I don't think we're going to see that happening. I mean, Bluetooth, unlike Wi-Fi and a lot of the others, was actually designed by radio experts up at Nokia and Ericsson. It's designed to be a radio that if there is interference out there, Bluetooth is the one that will kick everything else out. It is a very robust radio. It's been designed for situations like that. We've not really seen any of those issues in the real world. As I've said, you can go into, I mean, a train full of people with wireless headsets is about the worst possible environment because it's a contained metal cylinder. If it's going to break radio, that's going to break radio, and Bluetooth works in that.
I think there's a good question here from Leo Kaplanis. If you're in a broadcasting mode, how would the first pairing, what would be the first pairing experience? Would it need a code or something similar? Can you broadcasting, let's say, two different streams from the same source, multi-language from a TV?
Yes, you can transmit multiple different streams from a TV. They can be different languages. They could be different audio quality. Your limit is basically spectrum of how much bandwidth do you have against channels. And if you go to a lower codec rate, you can obviously fit more channels in. In order, how do you pick it up? Those broadcasters transmit information that your hearing aids can search for. Generally, you don't have much of a user interface, so it's more likely you'll search for it using your phone. So you can use a phone or anything else as a remote control. That can look and find out what broadcasts are there. Those broadcasts use human readable metadata, so it will come up with a list of sort of what it's seen, which might be channels or streaming things. And if you're using a phone, you can just tap which one of those you want, and it will tell your hearing aids to pick it up. We also think sort of for encrypted ones, and this may be sort of in gyms or the like, you'll see people developing little things like that, sort of little touch pads, and you just take your phone and tap on it, and the phone picks up the information and sends it to your hearing aids. But it doesn't need to be a phone. It could be your watch. It could be the little battery box for your earbuds or hearing aids. Anything that has a Bluetooth link to your headset can be used for doing that sort of thing. So we keep it very open as to the way you actually make this work and can pick it up.
Do you imagine it will be a like an app that Apple or Google make, or it's part of their settings, or that each product manufacturer would have to develop?
We would need the phone manufacturers to provide an API for this, and I suspect they would have their own app. But if the API is available, then anybody else can do it. So your hearing aid manufacturer can supply their own app. You can have a third-party app. I'm sure there will be people out there making their own apps for these devices because they think they can do it better. And that's what we see with today's products.
You're right. I have a question about the whole kind of setup. Whenever you speak about we are developing this new standard, is that in EMA?
Bluetooth.
Bluetooth
when I'm saying it, I'm talking Bluetooth.
Right.
Our aim is to do open specifications that anybody can take and use. We have something like 200 companies that are involved in doing this. A number of them really active, and they contribute engineers to do it, but lots of people that sort of lurk around and review stuff and come in with other ideas. So it's the industry as a whole that's doing that. HEMA's put a lot of effort into supporting the Bluetooth effort. And then, as Nikolai has said, with what he's talking about with HearStream, they're looking at how they can take that and make sure that really fits their particular user base of hearing aid users and the infrastructure that supports them.
Okay, thanks for that. And we have a question from John Hammer Messen. Additional dual mode question. Receiving classic A2DP and forwarding LE audio to the other earbud. Possible with the same Bluetooth radio?
It's possible. I'm going to sort of make a comment here. If you're talking about two earbuds that are on either side of your head, it's really difficult to forward Bluetooth between them because you have this big bag of water called your brain in the middle, which is particularly good at absorbing the 2.4 gigahertz radiation. Most people today that make earbuds, if they're connecting one to the other, they use a lower frequency radio, typically something called near field magnetic induction, to actually do that left to right transfer if they want to do it. So that it's possible. You probably wouldn't use Bluetooth for it. There are certainly people out there that are making sort of Bluetooth classic to Bluetooth LE adapters, not least because it's quite useful in testing and prototyping. Whether they're commercially useful, I don't know. But if you look at today's true wireless earbud industry, most of those use a different radio to actually do the ear-to-ear communications. That might transfer audio, it might just transfer synchronization information. But there are lots of little tricks like that that the user isn't actually aware of that's happening underneath to make things work.
I do not agree completely with Nick on this. I actually see a lot of manufacturers has moved away from NFMI and using 2G for signaling between DS, and with good results. Of course, there have been a lot of learnings in this space, but I see a lot doing that.
And I could hear that Lucas was laughing with this question. Why was that?
No.
No. You are.
Always good. I agree.
Okay, and then we have a few more. As it supports 192K, does that mean a 192K signal is encoded and sent wirelessly and then decoded into a similar 192K signal with meaningful content above 20 kilohertz?
I don't think you get much meaningful content above 20 kilohertz, to be perfectly honest. As far as I'm concerned, there is no meaningful content above about 14 kilohertz.
For you?
Most of us, just looking at the...
Yeah, most people.
I mean, if you have a pet bat, fine, but we're not actually designing for bats.
So 192K, that is the gold cable for Bluetooth connections.
I think my hearing, fortunately, is still quite good. Obviously, it's deteriorated with age. I am not convinced, if I'm sitting in a proper listening booth on this, that I think I can just about tell the difference between the 96 kilobits per second, the 24K sampling on stereo for LC3 and an original signal, but only just. If I go above that to the 48, I personally can't tell the difference. It is a very good codec. There will be people that insist you want to push it up to the top, but all the listening tests we've done, and we've done a lot of independent listening tests. We've got members to test this. We've also taken it out and commissioned tests from independent laboratories. And they're all saying that up at that top level, it really is indistinguishable from the original.
Yeah. So maybe now this is a little bit of a Danish session. then actually the objective assessment was actually made by SenseLab in Hørsholm, Denmark.
Yep.
Which are pretty good at doing subjective assessment. So for anyone interested, I think they should go and look up this on Bluetooth SIG.
I mean, at that top level, it's much the same as saying it's better quality because we've gold-plated the antenna.
Yeah, exactly.
Is it possible to listen to some examples on the Bluetooth website?
They are on the Bluetooth website, and there's a link in the presentation. So when you send that round, everybody can go and listen.
Yeah, perfect.
With a high quality headset, of course. Otherwise,
with a high quality headset. And I would also say from my own experience on that, high quality headset without noise cancellation.
Yes.
Noise cancellation, and when you push up to those high levels, you start to think, hang on, I can hear a difference. And then you realize it's the noise cancellation effects.
And don't use a headset with Bluetooth and SBC encoders, decoders.
And we do have SBC examples on the website as well, so you can compare SBC with LC3.
It's quite impressive. I think I listened to it. Right.
Excellent. Oh, we have more questions. Are you game for more questions?
Yeah, throw them.
Is there a purpose for supporting higher sampling rates then? That's a good question.
I would say yes, it's called marketing.
And is it not so that you're ready for whatever the future brings? It might at some point be useful.
We're having some interesting internal arguments at the moment as to what is the recommended one. And particularly we see some from Far Eastern product manufacturers. They are saying you have to sample at the highest possible rate you can. And we say, why? And they say, because it's a bigger number we can print on the box.
Mm.
And I mean, the audio industry has a long history of that. Yeah. If we say that most of this is for people wearing hearing aids or consumers wearing earbuds, which they're wearing in what's typically a noisy environment, you're not going to be able to tell the difference. But all we can do is sort of from writing specs to say, well, we've listened to what you said the requirements are. We're offering this. If you want to push the rate up, you probably won't hear the difference. You will notice the difference because your battery life will be shorter. And you need to decide what it is your customer wants most. And there is that trade-off that the higher you push the quality, the worse your battery will be, the sooner we'll have climate change. You waste immense amounts of power if you go in for lossless streaming. And I never see that being sort of marketed by Apple or whatever, that sort of if you support Trump and don't believe in climate change, go for lossless streaming. You will waste power.
But ultimately, I mean, it will be the choice of each manufacturer what they're going to do. If their audience are people who have a strong belief in that stuff, they will have to service them. Other people who are not so worried about their customers being picky about it will probably do something more sensible, I think.
I mean, the interesting thing, I think, with LC3 in particular, because it's much more efficient, we have these options that you can use lower bit rates and it will still sound good. Mm. And that means you can have a longer battery life, or you might want to put in some other audio processing algorithms, which you wouldn't have the power available to do if you were pushing up to the highest qualities. So it's up to manufacturers to think, well, we've got things we can play with. We can play with battery life, we can play with latency, we can play with audio quality, we can play with robustness, which means greater range. And there's now the ability to sort of juggle all of these things and decide what's the most important one for your particular product.
Yeah, and the bandwidth usage is important, right? So you can do more things on Bluetooth when you use lower quality. Right?
Yeah. And the other thing we're seeing is people saying, well, maybe we're going to put biometric sensors in because the ear is a great place to measure temperature or blood pressure or anything else. And if you do that, that also takes up power, and also you're going to have some Bluetooth connections doing that. So I think we give them a lot more flexibility, and people are going to have to decide just what they want their product to do. Historically, it's been a case with audio of we're going to make it the best possible spec. We're going to get THD down to 0. We're going to get the bit rate up to sort of essentially lossless. Because they didn't have much else to do. But with earbuds, there's lots more interesting things you can do with them.
Yeah, like you say, now we're going back to speech, and people are spending a lot of time listening to podcasts and other things, not just music. So they're not going to notice the difference. Anyways, yeah. And
with speech, you can go even better because you can put in something called packet loss concealment that makes up for sort of lost packets. That works really well for speech. It's not quite as good for music. So for speech, you can get away with really low bit rates.
Is that something that's already on the market in products?
Well, it's already in the LC3 spec. So
okay.
And packet loss concealment's already been there. Again, as I said, LC3 is a very good, it's a very modern codec. So it's actually built with the packet loss concealment built into it. So it's, we think, more efficient than most other codecs at speech because of that.
And when you're speaking about other algorithms, are you thinking of 3D audio and
I'm
thinking
everything. I mean, it's 3D audio. It's all of the things. I mean, what hearing aids typically do with presets is to try and understand the sound around them, so you can adjust the audio to cope with your environment. It's the ones that when you're walking down the street with your earbuds blasting something, it will actually listen and hear that there's a car coming and tell you that, by the way, you might want to get out of the way. Sort of parents relaxing in the evening, it can pick up your baby crying and tell you that maybe you should turn that off and go and see the baby, or if you're not a very good parent, you can just ignore it. It's a feature you configure when you buy your earbuds.
Yes, if you're busy listening to your lossless audio.
Yeah.
Excellent. We have a question from Nikolai Witt. How about concurrent data and audio transfer, which is a challenge today with Bluetooth and Bluetooth Classic coexistence? Advanced applications require live data exchange combined with duplex audio. Regards.
As long as it's not massive data transfer and you're not running up at the very highest audio qualities, that shouldn't be an issue. I mean, you can get a quite acceptable audio quality up there, probably with less than a third of your bandwidth. So you can use the rest of that for data transfer. Depending what the data is, I mean, if it's time critical data, you may be using the same isochronous channels for that data that you're using for the audio. When I say the same ones, sort of parallel ones, you'll be using some for, and we've got some people that are building ECGs into earbuds, and those are looking at using isochronous channels both for streaming audio and also another set of isochronous channels for taking the ECG data down. And that's where you get sort of the interesting ones. And if you can try and use something like an ECG, you can attempt to pick up somebody's mood. So you can then use that to select what music you stream to them in the hope that you might make them sort of calm down. So we're seeing biofeedback coming into some designs for earbuds.
Wow. Is that something you've worked with, Lucas?
Yeah, so yeah, what I would comment here actually is that it all depends on the controller, because it's all about the scheduling. It's, of course, when you have BLE support and Bluetooth Classic, you need to, the scheduler have a lot of work to do to you know, to schedule everything correctly and accurately, and make sure that the BLE gets the airtime and the basic rate as well. So it all depends on the controller you're using and how the scheduler works. But it's definitely possible with the use case you're describing here.
And I should reinforce what Lucas is saying. Some of the stuff we're talking about here is stuff which may not be possible on most chips, or certainly commercial ones today.
Yeah.
We live in a funny little world writing specs, because we've all got our heads in some science fiction world that's 5 or 10 years in the future. For manufacturers that are actually making some of these products today, you're going to start off with simpler applications.
I have just looked at the clock and we have gone a little bit over time. So we might need to wrap it up for today. Do you have anything else to say? Any of our panelists?
No.
I think we've covered it all.
Certainly not, but a lot.
Yeah.
What I'd like to hope today is that we've opened up your imaginations a bit, that we think you can do things with audio which you probably might have wanted to do but can't do in the past. So sort of believe the impossible, as it were. If you have thoughts, if you think there are any questions, just drop us an email. We're very happy in the development groups to understand what people are thinking about so that we can try and design for every possibility. So if you've got ideas and you want to discuss them, just come and yell.
There's still time to get your ideas in there.
It may be, well, not in the version that's going out now. We're at the point of saying no changes, otherwise we take you, sort of throw you out somewhere. And but there will be next versions. And we may be able to do it with what we have today.
Excellent. Well, I would just like to say thank you very much to all of our panelists today. Your presentations were great and really easy to follow compared to some other technical webinars we've attended. And yes, please do join us for our future Danish Sound Cluster events. You can sign up on the website and sign up to our newsletter as well.
And also a great thank for Bo and Lucas for joining the panel discussion.
Thank you.
Thank you very much.
Yep.
See you next time.
Yes.
Thank you.
Bye.
Bye.
Bye.